Hi, and welcome back to Dev Show. My name is Sherry List, and I'm your host today, together with my good colleague, Rasmus Jack. And as usual, we prepared an amazing hour show for you with a great speaker and very interesting topic. Rasmus is going to talk about it in a moment. Before handing it over to Rasmus, I want to mention three things for you. One is that please try to use the chat and let us know that where you are watching us from. We're really interested in knowing that. And also talk to each other. And you can use the chat to also ask your question from our speaker. He's going to answer that during the Q&A section. And you might be able to win some swags as well if you ask the right question. But be sure of that. And for the speaking of the prizes, the second part is that all of you are going to get the Azure Heroes Learner Badge. I'm going to highlight the URL for you in the chat and also on the screen. And later on, I'm going to talk about the program a little bit as well. And then the third part, speaking of the prizes, we also need your feedback. We want to improve. We want to know that which topic to cover, and we are going to highlight the URL for the feedback as well. And one of you, also the one that who actually is one of the people that give the feedback, is also going to get some swags. So handing it over to you, Rasmus.
Yeah, thanks, Jerry. And important thing, if you want to enter the raffle for the feedback form at least, then you need to put in your email address or some way that we can contact you in the field that says if you want to put in the contact details, because otherwise it's going to be anonymous and we cannot find out. Even though it's great feedback, great questions, or anything like that, then we cannot contact you, obviously. So. But a lot of good things on the agenda today, outside of all the swags that is possible to get from both questions and feedback. We also have an awesome topic on the agenda, which is today GitHub in action, and we in this topic we're gonna learn about what is GitHub Action. How can it be used? Our speaker today is going to show some demos and examples, so it's not only going to be slides. We're also going to learn about workflows related to CI/CD, open source projects, and also how to extend workflows with your own actions. So really good content in today's topic. And most of you, or a lot of you, might know the speaker of today because he's kind of a known figure in the community. Hi, Morten. So
Hi.
As you can see, our speaker today is Morten. Morten, he works at Umbraco, where he helps out building the Umbraco cloud as a service. Morten is also MVP for Azure. He's an Azure lover and a community addict, he says. And in Copenhagen, he helps organize Copenhagen.net user group, Azure user group, community-focused conferences like MicroCPH and Intelligent Cloud Conference. So really a lot of great stuff Morten is doing out there. He's also, this is not something that he told to us to say, but he's also a chili enthusiast. He's also a taco lover, and the taco lover we are going to get more into, Morten. And then you also love Lego. When we go to the taco lover thing, yeah. If somebody is following you on the social media, at least on Instagram, you have shared a picture about an awesome machine. Can you talk a bit about that awesome machine?
Well, I guess it's very simple. It's a grinder for grinding corn. And that's the only thing it does.
And it's not a small one, right?
No, well, it's a tabletop grinder, but it's quite big. It's like 35-40 kilos because there's a giant engine in it, and it has two stones, I guess volcanic stones, which grinds together to grind the corn.
So who don't want a 35 kilo weight machine only to grind corn in the kitchen? It's awesome. That's really what you call passion, right?
In a small Danish kitchen.
In a small Danish kitchen.
In a small apartment.
That's awesome, Morten. I don't want to take, sorry.
Okay. Also, before we give the stage to Morten, there are two things. One is that Morten is also known as Azure Hero. So that's why that I always wanted to make this joke that the Azure Hero is Azure Heroes is approved by Azure Hero. So that's a fun one. And then the other thing is that many of you might not know, but he's a pretty good ally for the Hack Your Future program as well. He's helping actually trying to support the graduate and the students there very much as well. So thank you very much, Morten, for doing that. And with that, we can say that the stage is yours.
Yeah, welcome to the Tech Show. Look forward to see your presentation, Morten.
Yeah, cool. Okay, well, let's get started with GitHub in action. So I guess I don't really need this since I was already introduced. So we'll just skip this, or I'll just say that the conference part was pre-COVID-19, unfortunately. There's not a lot of that going on right now. But let's jump to the agenda. And today we're going to talk a little bit about YAML and see a little bit of YAML. But no, this is what it actually looked like. So this is what I wanted to go through today. So a little bit about the features when we talk about GitHub Actions, the service. What is it you get? What does it cost to use it? And then jump into what is actually an action when we talk about GitHub Actions. What is the action itself? Then we talk about, I think I actually switched these two around. So I think we'll talk about GitHub events and then workflows and then syntax, which will involve the YAML part. So there will be some YAML. And then finally, we'll have a few different demos related to some of these topics of the agenda. And I'm especially excited about the last demo, so be sure to stick around for that. So I think the last demo is probably the coolest of them all. So hopefully you'll stick around to see that as well. All right, but when we talk about GitHub Actions in the general sense, it's a service that includes a bunch of different features. And action is a thing by itself, but GitHub Actions is kind of the entirety of the service, so to say. And that includes a few different things. So what you get as part of GitHub Actions is the ability to run builds, tests, and deploy in your code, the continuous integration, continuous delivery part, which you'll probably see in most mentions of GitHub Actions and some of the common use cases for it. You can also use any language, which means you can have, or you can build more or less everything. So everything that, or anything that you can put into a GitHub repository can be built and tested in GitHub Actions. You can run these builds or tests on both Windows, Linux, and Mac. And you can even use containers as part of it. You get a built-in secret store, which we'll also take a brief look at. In GitHub Actions, it's very basic, but you do have a place to store secrets where once they're stored, you can't actually go and see them afterwards. But you can then use them in your workflows as part of this. Yeah, and then just in general, there's like the whole community of GitHub. There's a lot of actions that you can use that are ready to use. So just getting started, there's a lot of stuff that you can use out of the box that's available to you. That's the community and companies contribute, and you can also build your own if there's something you need which is not already available. But just the wealth of what's available is at your disposal as part of this. And so one of the things that you probably also wonder about with services like these is, what does it actually cost? So I just wanted to briefly mention this and include this as part of this presentation, so you get an idea of what it actually costs to use GitHub Actions. So there's a lot of free minutes included out of the box. With even though you have a free plan, you get 2,000 minutes per month, which is 33 hours of using or executing workflows. So that's quite a lot. And if you need to use additional minutes, then you can see the prices listed here, depending on which type of OS you use, if it's Linux, Windows, or Mac OS. You can even use the self-hosted option, where you run it on your own machine or your own server. So if you have an old server in your basement that's no longer running Team Foundation server, then you could run this GitHub runner or GitHub Actions runner on that server, and then you don't pay for it. But it is fairly cheap, and if you were to run a workflow 24/7 round the clock for a full month, then it would be $335 per month with the free 2,000 minutes excluded from that. So fairly inexpensive and free to get started with, if you stay within the 2,000 minutes, which should be quite enough to get started with. All right, but what is an action actually? So we talk about GitHub Action, but what is the action part? So actions are individual tasks that you can combine to create jobs and customize your workflow. You can create your own actions, or you use and customize actions shared by the GitHub community. So I wanted to underline the individual task part. An action by itself is a standalone command or a task that is used to create a job or jobs. That can take any number of inputs and optionally provide an output. But generally they take some form of input and then do something. And that's very much up to you what they actually do, and if there's any kind of input. So that could be building a project, or it could be invoking a third-party service. So if you need to run something as part of your workflow that, for example, calls out to Slack, then that's something that you could incorporate into a workflow. So just additionally, I want to mention, or underline a few important things which we'll go through as part of this presentation. The actions are combined into steps to create a job which runs as part of a workflow. So what we'll talk about, or we'll talk more about these different components throughout this, but I just wanted to highlight how it's composed, or how it all fits together. And we'll go through this, and then we'll come back to this definition again. In terms of actions, there are three types of actions, but essentially two ways of creating an action. You can build a Docker container with anything in it really, or you can create a JavaScript-based action. The actions require a metadata file to define the inputs and the outputs, and the main entry point for your action. The metadata file must be either action.yml or YAML. So a composite run step allows you to combine multiple workflows, run steps within one action. So kind of like with a test setup, where you set up the test in step 1, then run the test step 2, then tear down the test in step 3. One thing you can do in a run step is to run a shell command. So instead of creating an action which is based in JavaScript, you can just run something from a shell script. So if you need to run something in Bash, a Bash command, it could be maybe a Git command, then you can run that just as an action, and then you can combine it through an action and through the action definition, the action.yaml part, into multiple steps. So if you need to run multiple Bash scripts, then that can be done through the combination of one action. So here's a very basic, what a very basic action would look like. So this is just my own GitHub repository with a very simple action in it. As you can see here, I've highlighted action.yaml, which is the definition. And then I have an index.js, the action written in JavaScript. It's committed with the node modules in the repository. It could also be committed as a single distribution file. So if you use a tool like Vercel NCC, which is a simple CLI for compiling Node.js modules into a single file, then that could also be an approach. But for this sample, I've just committed the node modules, which is using some standard GitHub modules as part of it. But the basis is just the action.yaml and then index.js. So if you take a look at the action.yaml file, what you see here is the definition, a name, what it's called, a description, just something you can see as part of the run or when it's available in the library of actions. You can see I've then defined the inputs. It takes who to greet as an input. There's a description for that, and then it's defined as being required. So that means that I must supply the who to greet parameter as part of my step to use this action. And then I have a default value, which in this case is for devs community. And then I've defined my output, which I can use throughout my job, or if I have other steps that need to use this output. And then I've defined the run as well. So this is using Node.js 12 and then the index.js file to run. And so if we take a look at the index.js file, which is the action itself, so the thing, the task that actually executes, you can see it's very basic, but just highlighted the three parts to it. So the first part is that it gets the input, the parameter that's passed in, so the one I defined in my action.yaml, who to greet, and then it writes it out to the console where I say hello and then who to greet. Then the next part is that it's capturing the current time of day, and then it's setting that as the output. So the time of date is what I can then use in the other steps or as part of my job in the workflow. And then last part is a payload. So that's just printing out the payload for what it receives here. So we'll see that in the demo a bit later on, but that's just to show that you can use the GitHub context to actually print out the payload that you get in through this action, and which is available. But it'll probably make a bit more sense when we see that later on. So the next parts that we want to show here is GitHub events. So let's talk a bit about that. So GitHub events are the events that can trigger the workflows. And the definition that you see in the documentation is this: that you can configure your workflows to run when specific activity on GitHub happens at a scheduled time, or when an event outside of GitHub occurs. And this is really where a lot of the power of GitHub Action lies, that you are able to react to the events that happens within your GitHub repository or which happens outside. But mostly, I think the interesting part in this is reacting to stuff that happens around your project in GitHub. And so there's three types of events that you can use for this, and that you can use to trigger your workflow. The first one is scheduled cron job. So traditionally, you set a schedule for when a workflow should run. So if you have something like a nightly job, a nightly build, nightly test runs, then you can use this scheduled job to trigger that workflow. You can trigger it manually as well. You can use a REST endpoint to call it and then specifically ask for a workflow to be called. And then there's the webhook events, which is the rich hooks, the rich range of webhooks that are available from GitHub. And I've just listed a bunch of these here. There are many, many more, and I've added a link to the documentation, which has the list of all of the webhooks which are available. But generally, something like push, when new commits are pushed to a given branch in your Git repository, that's something you can react to and have that trigger your workflow. When you create or publish a release on GitHub, when someone watches your project, when someone submits a pull request to a project, or when an issue is created, when an issue is tagged with a label, for example. And there are really many more steps. But I think the really interesting ones here are the pull requests and the push events. And that's those are the ones I'll try and highlight through the demos later in this talk. But yeah, so I would encourage that you go to the documentation here that I've listed, events that trigger workflows, and then have a look at the different webhook events that are available from GitHub to get an overview of what you can actually use to trigger your workflow. And speaking of workflows, the definition of a workflow is that it's a configurable automated process made up of one or more jobs. You must create a YAML file to define your workflow configuration. And we'll talk a lot more about the syntax in the next session. But the thing to note here is the workflow file. There's a YAML file, and that you have within, so from the root of your GitHub repository, you create a folder called .github, and then you have a workflows folder, and then you can create any number of workflows in there that you can use for that specific repository. And one thing I wanted to highlight is that it's more than just continuous integration and continuous delivery. That is, of course, a big part of it, and the build, test, deploy is probably the most common scenarios. But really, you can use it for automating almost anything related to your GitHub repository. And you can use it to push packages. So if you have something that at the end of a build needs to push an npm package or a NuGet package or whatever else package, then something you can set up as part of this. You can use it to comment on pull requests. So if you have an open source project, then you can use it to either read the comments as they're coming in or reply to them immediately, maybe even assign someone to a pull request automatically. You could use it to kick off acceptance tests. So if a pull request is open, then run the acceptance test to see if everything is fine, and then maybe even comment back on the pull request with the test results. You can also use it to run Terraform infrastructure as code, so building up an environment. I think there was not too long ago a session around Terraform here on 4Devs, which showed a little bit about Terraform, and that'll also be part of the last demo. But won't focus too much on Terraform, but it's part of it. And I hope at least you will see that it's one of the powers of using the combination of GitHub Actions and something like infrastructure as code. And then you can run jobs in parallel or in sequence, and we'll get into that in the next section. You could also use it to post to Slack, Twitter, Teams, whatever you see fit, maybe even Twilio, if you need that as part of your workflow. So I guess this is almost the mandatory Lego comparison, but really how you could approach it is that the actions in GitHub Actions is the building blocks of your workflow, and the plate which you build upon, I mean, that is the workflow. Right? You combine it, you combine your actions to make up the workflow that you need for your specific scenario. So let's have a look at the syntax. And this is the part where we'll dive into a little bit of YAML. So if you remember from earlier, the definition had that a workflow is a configurable automated process made up of one or more jobs. So let's talk a little bit about jobs. If we just have a look at this overview, I think that's a fairly good overview of how all these different concepts fits together. So we talked about the GitHub events, which triggers your workflow. You have a number of jobs. For each job, you can have a number of steps, which each have an action or multiple actions. And these jobs all run on something. The runner is something we haven't really talked about yet, but these are the different combinations. Oh, sorry, the different components of a workflow. And I think this is a pretty good visualization of how it all fits together. But the runner part is a server that has the GitHub Action Runner application installed on it. You can use a runner hosted by GitHub, or you can host your own. And so it's really the OS that's executing your actions. So you define it as part of your workflow, what type of runner you actually run. And a job can have a runner, or each job in your workflow can have its own runner. So you could have one job run on Linux, you could have another job run on Windows, and a third on a Mac, if that's what you needed. But yeah, that's the combination of things. So if we look at the basics of a workflow and the YAML that's involved in this, then you have a few different things at the beginning of a workflow. First, the name of your workflow, which is optional. If you don't give it a name, then it'll just use the name of the YAML file and the path to it. And then the next thing which is required is the on part. So that's the trigger for when to run that workflow. So for example, if it's triggered on a git push, then you would define it in the on part of it. And then you also have environment variables that you can specify both at, so you can use it at multiple different levels of a workflow. So both at the workflow level, at the job level, and the step level. So you can use it throughout the workflow or just for specific parts of it. And I'll show that as part of the demos as well. But if we take a look at what it looks like in a YAML file. So here is a simple example. So you see that we have the on part, on push to the branches main, and for devs online, and to releases. So that's whenever something is pushed to main, that's when it'll trigger. And also for these specific tags. So if something is tagged with v1 or v1.001, 1.0, then this this workflow would also trigger. And then beneath that, you can have the environment variables, which is just really a key value map of the variables that you can use or that you want to use as part of your workflow. So here we've specified a key called environment, and we give it the value production. Next, we have jobs. Here we have the first one, or the top one, is we have two jobs, and these will run in parallel. So the first job and the second job will run in parallel. If we run it to run them in sequence, then we can do something like this, where we specify that job number 2 needs job number 1. And then here we have a third job, which specifies both job number 1 and 2, which means that job number 3 would not run until both job number 1 and 2 are done running. And then what I mentioned before with runs on, you can see here just an example of runs on with Ubuntu latest. So if we wanted to run this specific workflow on a Linux OS, then this is what we run. You could also specify Windows or Mac OS, or if you're hosting it yourself, then you would specify that it's a self-hosted runner. And then I think another important aspect to highlight here is how to use outputs. So I showed as part of the action that you can specify an output that you can use throughout your workflow. So here, if we highlight here, from these steps, we define that the output from step number 1 and number 2 can be used from other jobs. So here it's just doing an echo and then hello and world, but we can use this this output in the next job, as you see here. So we depend on job number 1 in job number 2, so that it runs in sequence, and then we can specify that from job number 1 we want output 1 and output 2, and then from here it would actually print out hello world. And then the next part of it was the step. So we had the workflow, which is triggered to run a certain number of jobs, and then within a job we have a step or steps. So here is how we can use steps, and we'll see this in the demo as well, that we specify the 2 functions that are used here is we set up Terraform, and then we use a default or standard GitHub action called checkout. And here you can see that we also specify the version. For the checkout one, we specify that it's version number 2 that we want to use. And for the setup Terraform, we specify that we want to use the version of this action, which is in the main branch of this public repository. And you can also specify actions within your own private repositories, which might not be public. And that's what you have in the first demo. But just to summarize again, that actions are combined into steps to create a job which runs as part of a workflow. And with that, hopefully we've kind of summed up how we can use action and how we can compose a workflow. So I think it's demo time, or we could almost say that it's YAML time. So let's just jump to the first demo, where we see our custom action in action. So if we jump over here, then just to show you that I have my action locally. So this is the one I showed in the beginning, where I have a very simple JavaScript-based action, which takes an input of who to greet, and then captures the time, and then outputs hello and with who we greeted, and then the time.
Sorry to disturb you, but even though I have really good glasses, can you zoom in a bit?
Yes, of course.
Awesome. I'll jump out again. Sorry.
Yes, here we go. So hopefully that's a bit easier to see. So yeah, well, anyway, so this was just the action I showed before. So if we jump over to GitHub, you can see I have my action here. What I've done is I have created a workflow which uses this action. So a very basic one, whenever I push to this Git repository, then I have this job, a job to say hello, which uses 2 steps. Because it's a private action, I need to check out the current GitHub repository, and then I use the action called hello, and then I say who to greet, Sherry and Rasmus, and then I can use that output and print it, or the output from that function, or sorry, from from that action, and print that. So if you jump over here into the Actions tab, that's where you can see the actions that you, or sorry, the workflows that you have available with the actions that you want to run. So I ran one, so we don't have to wait for it here. So here I can see the output of what happened when I triggered this workflow. So if we open this up, you can see the workflow ran, and then it says, hello, Sharon Rasmus. And then this is the payload from the incoming webhook. So maybe not super interesting in this regard because there's a lot of information here, but that is all the information that you can use however you see fit, based off of the webhook that's coming into this specific workflow. And then here we get the output time. So the time was 1 o'clock, almost 2 o'clock, when this ran and when we greeted someone as part of it. So a very basic action and a very basic workflow to show how that action can be used. Yeah, and so if we jump back into, oops, that's the wrong one. Here you go. And then the second demo, which will be around commenting on a pull request when it's opened and when it's merged. So this is something that could be used for open source projects when you want to react to pull requests coming in. So let's have a look at that. So again, whoops. Okay, this is already zoomed in. Okay, so let's see here. What we have here is a workflow which triggers on pull requests when they are opened. We don't worry too much about this right now, but when it's open and when it's closed. So when we open a pull request, just do this. So you can see we have a condition here which says when a pull request is created and when it's not closed, then we run this job where we comment on the pull request. And then it uses an action called GitHub script, which allows us to comment on a pull request. So you can see here I'm constructing the comment which should be added as part of opening up a pull request. So if we jump to the GitHub repository here, so let's say I want to improve the README file with a valuable addition, and then go and create a new branch so we don't commit it directly. Open up a pull request, and then say added some valuable information. And then create this pull request. Then we should see that within too long that the workflow will start running. So you can see here that it started. The comment on pull requests, initial comment is queued, and then we also have a thank you, but we'll get to that afterwards. And then you can see comment popped up right here. So you see this is my automatically generated comment for when a pull request is opened. Awesome, we love getting pull requests with a thank you note, and yeah, just some information. So this is mostly just for testing and for mentioning the person who pushed this comment. So if I merge this pull requests, then we should see within long as well that we get an additional comment with a thank you note because this pull request was merged. So we'll see if it doesn't pop up immediately. So let's just go look at what happens when we close a pull request. So the first thing we do is, again, a condition on pull requests. We check that it's closed, the pull request is closed, but also that it's merged, because we only want to post this thank you note when the pull request has actually been merged. So again, we use an action called GitHub script to create a comment on that pull request with a note on, or a thank you note really. So let's see, it popped up right now. So you can see here, it popped up saying, congratulations, your pull request has been merged, and a thank you note. So this fairly basic, or maybe not too basic, but fairly straightforward way of using a workflow to comment on pull requests without really having to create any code, just using actions which are available on GitHub and using GitHub Actions as part of this. So if we go back to the slides and then go to the third demo, which is creating a test environment for new pull requests and deleting that environment when a pull request is merged or closed. So this demo probably requires a bit more explanation, because there's a lot of moving parts in all of this. So what we have as part of this pull request is that we have a GitHub repository with a web application in it. That web application needs a database to run, and it needs to run as a web app. For this, we're using an Azure App Service web app. So that means that when we create, or when a pull request is created and we want to test out this web application, we need to create an environment which we can use for testing this addition to the PR, this addition to the web application as part of the pull request, by creating a SQL server and a database, creating an app service plant and a web app, and also adding application insights, which, if you're not familiar with that, it allows us to do some logging of errors and possibly do some get some insights into performance of the web application running. But if we jump to the last one here. So if we first take a look at GitHub, so I have this GitHub repository with my web application in here. I have the environment, which is defined in Terraform, so using infrastructure as code. I have all of these components which are needed, I have scripted here, so I can create it from the workflow. And then I have my workflow in here. So let's see, if we first take a look at the different components. Actually, let's kick it off first, because this will take a bit of time to actually create the environment. So if you go into views, then probably home, index, and if we can add something here, let's edit this one. So just adding this, and then we'll create a new branch, propose changes. In this, so I'll just submit my pull request here. All right, so that will start running, and I'll just show you quickly that in Azure, these are the resource groups that I have available. When we come back to this and we refresh, we'll see that a new resource group is created, and then we can go in and see the different services which was created as part of this. So you can see that it's kicking off now, and then while that is running, we can go and check out the YAML for this workflow. So the first thing again is that we named this specific workflow for pull request environments. We are triggering on pull requests when they are opened and closed. I've commented out this part for now, but we can further specify when we want to trigger this workflow. So for example, we only want to trigger when there are changes to the actual web application. And if we have documentation in the root, for example, we don't want to trigger the creation of an environment once, if only documentation is updated. So we don't need that. So that's something we could add as well. But then the first part, which will run, we'll just close some of this. No, maybe not. But yeah, so the first thing we do is we start provisioning the environment. And that's what we're doing here. So similar to commenting on the pull request, we react to pull request, or we have a condition for it, saying when it's a pull request and when it's not closed, then we start this job, which has a bunch of different things. And this might be a bit overwhelming to look at. But the important thing to point or to take note of here is that we use the secrets from the environment. So over on GitHub. So if we go to settings, and where are we? Secrets. Here, you can see I've defined a bunch of different secrets here, which I can update, but I can actually see them. So these secrets are used as environment variables as part of this workflow. And then I'm also using some information from the pull request itself to make it unique so that I can have multiple pull requests running with each their own environment. And then the next parts are Terraform. We don't need to go into too much detail, but that's just setting up Terraform with my Terraform scripts, which is the definition of the environment to create, and then creating some output variables, which I'll use as part of building it. So this first part was provisioning the web app in Azure. So the next part is building it and deploying it to the web app that was just created up here. So this part will actually run on Windows. And that's mostly because for this specific build, we're using MS Build, and then it's just easier to run on a Windows machine. But then it's taking some of the outputs from the previous step. You can see similarly to what was shown earlier, that we provisioned, or we have the provision job, which has output of the web app name, and then we can specify that as environment variables. And then finally, when it's done with provisioning and deploying it, then it will post a comment on the pull requests with information about the environment which was created. And so if we go back to the pull requests, let's see if it's probably still running. Yeah, so it's done running the provisioning. So if we go into Azure, then we should see, yeah, we have a new resource group in here with all of the resources which are specified as part of the Terraform setup. So you can see I have a SQL database, SQL Server, app service, a web app, and a plan, and then application insights. And then once it's done building, then it'll post a comment. So hopefully that won't take too long, since we're also very close on time. So I'll just show really quickly as the last part that we also have this final part, which won't run as part of the pull request being created, but once the pull request has been closed. So here we're also saying on merge, but that we might just, it might be sufficient to just do it on closed. But what we want to do is basically tear down the environment which was created for this specific pull request whenever the pull request is closed. And for that, we're also using Terraform and the Terraform state, which is in blob storage. And then based off of that, removing the environment, and then again, posting a comment to the pull request saying that the web app for this pull request has been deleted because the pull request was closed. So again, using some of the same details of commenting on the pull requests. So let's see, that's still in progress. It's because it's taking a little bit of time to deploy to Azure, but I think it's almost there. So you can see here that was deployed. Oh, now it's going away. It was deployed to this Azure App Service web app, and then it uses the GitHub script to post a comment to the pull request. So if we go back and then we go to the conversation here, you can see it posted a comment and it included a URL for the environment which was just created. So if we open this up, we should be able to see the changes. This might take a little bit to load because the environment was just created and we just deployed to it. And there's nothing warming it up. So this is the first hit to that website. But yeah, I mean, this was essentially what I wanted to show with this demo, that we can use GitHub Actions to create an environment or create a test environment for our pull requests using something like infrastructure as code to provision the environment. So here we go. So this is my change, which I added 4 devs and Azure plus GitHub Rocks. Yeah, and that was pretty much what I had to show. So I only have this slide here left. So here we go. Yes, thank you for watching. Hopefully you got something out of the demos and hopefully inspired to try out GitHub Actions.
Great. Thank you, Martin. And we have actually a message for you. So
yes,
especially your very first demo was very awesome. So we have hello, Martin, from Sherry and Rasmus. We just deployed it to the production.
Hello, Martin.
yes.
Yeah.
So,
and of
so
course,
we have, yeah, it works, of course. So we have some questions from the audience. I know we only have 5 minutes left, but let's take some of them. So the first one we got in was from Baha. He talks about his experience with workflows and that it's not able to share the artifacts across workflows unless you're using external storage. So this forces you to create large workflows. What is your experience there with this one?
Well, I wouldn't say I have experience with that in GitHub Actions. I have experience with it in Azure DevOps, but I haven't actually gotten to this in GitHub Actions yet. Okay. So my main driver for trying it out and using it was to try and basically create environments as part of getting a pull request. So that's been my main driver for working with GitHub Actions. And then just seeing how much you could do with actions which are available. So without having to create your own custom actions, and seeing how much you could do with what's available from the community and from GitHub itself and from Azure, for example. So I haven't actually gotten to this yet. So I can only say yes. That's a pain point, something that probably hasn't gotten to GitHub Actions yet. But I'm sure that's probably something they'll get to. And I mean, there's a lot of learnings from Azure DevOps, and I'm sure those two teams talk together since they share a lot of internal bits. So I can imagine that they'll talk together. And I think if the community highlights this as an obstacle, that is something they can use to improve upon it.
Okay.
Yeah.
And talking about Azure DevOps, we also have a question how you would compare the capabilities of GitHub Actions with the Azure DevOps pipeline. So I think a lot of developers is asking this question right now.
Yeah. It's a good question. I mean, there's a lot of similarities. There's a lot of commonalities in it. So I think I mean, they're pretty close, I would say. I use Azure DevOps on a daily basis. And I can point to a few things that you can't do in GitHub Actions. But other than that, they're fairly similar. And I think when you consider that GitHub Actions is fairly new, that they're probably playing catch up to Azure DevOps. And I think we'll see more and more capabilities pop up in Azure DevOps. But I think they're very similar. But I think one of the big benefits of GitHub Actions is the fact that you can use all of the webhooks from GitHub as triggers. But I also saw that I think it was last week that Azure DevOps included as part of their last sprint that you can now trigger so you can trigger Azure DevOps pipelines from GitHub Actions. So you could kind of use the best of both worlds. So you could trigger get your triggers from GitHub, but then actually invoke something on Azure DevOps as part of your workflow. So I think they'll probably melt together at some point. At least that's what it seems like. Slowly melting.
Yeah, exactly. Sherry just approved that we can go just slightly over time today. So maybe let's go through a couple of more questions here, if you're okay with that, Morten.
Yep. Sure.
So we have one more question from Rasmus here. So how is the Actions development experience? Can you execute debug the workflow in the YAML locally?
That's a good question. I haven't actually tried that. Yeah, that's a good question. I think it probably depends. I mean, the actions can be a Docker container. So then it'll just depend on your Docker container, right? And what input you take. For the JavaScript, I haven't actually tried to run it locally yet. I just tend to push it to GitHub because it's so easy. Just push your changes and then see the output. So I haven't actually debugged it locally. But I think one thing you could probably also do is use the self-hosted runner and install that either on your laptop or in a Docker container, and then attach a debugger to that. So I mean, for the first time you're doing it, it'll probably be a bit involved, but I think that would be possible. But beyond that, I don't have any experience with local development.
Okay.
Aside from just JavaScript, which is not my first language, so I'm just kind of struggling.
That's you, Sherry, right? So
yes.
Okay, and the next one is from Esteban. He's asking if your repo will be available later so they can try it out.
And I promise.
Yeah, sure.
Already I answered yes on behalf of you.
Okay, perfect. Sherry says yes.
Yeah, Sherry says yes, then it's yes. Yeah, and then we have one last question here. So how does the URL is built to be available in the GitHub Actions environment? There's the URL.
Well, that's output from Terraform.
Okay.
So let's see, that was the last one. So as part of my Terraform setup, I've defined some outputs, which will be posted to back into the workflow. So you can see here, I'm this is the URL for the web app that's been created. So I'm using the Terraform Azure provider for that. So this is the name of the web app that was created, and then I'm getting a variable from there called default hostname, and that's what I set as an output variable. So I can use that. Oh, I can show it in here as well. In somewhere. Let's see. Yes, here I'm capturing the output. So this might be a bit roundabout way, but this was the only way I could get it to work. So I'm defining an output in this step, and then I'm using a Terraform command called output to output the variable from the Terraform output. So it's kind of double output, I guess.
Okay, awesome. So thanks for all the really great questions to the audience here, and thanks for answering them, Morten. So Sherry, do you have anything to add?
Yes, I wanted to say that part. I mean, now before Morten is going to choose one of the questions for the that is going to be the winner. I also ask people that if they are using GitHub Actions already. And Jonas Bramso, he mentioned that he does that, and I asked for some tips to share for the people that they want to kind of that to start using that. So this was the first one, that check the GitHub Marketplace before writing your own. That's a good one.
Yes.
And the second one, if you write your own, publish it to the marketplace, contributing back. That's always a good thing to do. And I guess there was a third one as well. Remember, if you want a status badge on your repo, it will be it is the pre-workflow as well. I guess I covered all of them. Thank you for sharing that. And you got a lot of hi and thank you in the chat as well. So I guess we can mention you need to actually choose.
Choose. Yeah. Well, I'll choose Rasmus for asking most questions.
Yeah. That's true. Yes, we can go that. Or actually, we can do one thing. I would say that this is a good day to give actually prize to everybody. So that asked the question. So for I guess there are 3 or 4, and also one for Jonas for sharing the tips as well. And so for all of you, I guess the best way to get it is to send either Osmos or me an email. So you highlight it here, and so mention your name, and then we will just take it from there for you. Okay. So thank you, Morten. You will also get a prize. So. Maybe I'm sure stuff that I got it from you. No, just joking. Okay.
Yeah. So as you said in the beginning, we want the feedback. So let's just move on to the other slides. But we still want your feedback and also prizes to be giving out during giving the feedback. So please give us fill out the form or give us feedback on Twitter, #DevShow, somewhere else where you can find us.
And we are actually trying to find the speaker based on the feedback that you are giving to us, the topics that you want to learn, you want to hear. So we are reading that, and we are trying to improve as well as we go. Definitely. And I also already shared the URL as well for Azure Heroes Learner Badge that we have. So to get it, just scan this QR code, and since it's based on public blockchain, you need to, if you don't have a badge before, for the first time, you need to download a wallet from a partner engine to store this there. And remember to have your password, because if you lose it, you would lose your whole wallet. And yeah, I learned it in a hard way. So remember your passwords. And yeah, if you want to know about the program, you can go to aka.ms/azure.heroes and find out about all the different type of badges that we have, and nominate yourself or a community friend there as well. And once you have your Azure Heroes badge, you can actually add your wallet to this community page that we have, which is azureheroes.community. And then the fun part is that you can find the other Azure Heroes around you as well. So the one that you added their wallet there. And whenever that you don't want to be listed there for whatever reason, you can easily just remove yourself from there. And back to you, Cosmos.
Yeah, what is coming up? We of course have a lot of awesome stuff still on the dev show. Next week we're gonna one of your requests in the feedback form. We're gonna have Chris Noring back, which was the first one on the dev show. He's gonna talk about the Blazor, and then we have the Cloud Secret to go with Thomas Kastrup talking about the IoT and green energy. Also, that's your show, Morten. So that's the 10th of November at 3 o'clock, and then you can just stay seated for the same day at 4 o'clock. Then you can hear Mark. Mark is also listening in today, I saw, and he's gonna talk about how to deal with persistence in the serverless application. So hi, Mark. We look forward to have you in the show next week. And then the week after, we're gonna have Vakas back. Vakas from Maersk. He's gonna talk about micro frontends in the cloud, from theory to practice. So again, looking a bit more under the hood of what they're doing in the engineering department in Maersk. So that's also gonna be awesome.
And I would say that this one is for you, Morten.
Yes. Virtual Azure Community Day. A joint effort by a bunch of different communities, including ours here in Denmark, I guess, because we have a very secret track. It's actually called Cloud Secrets. So a specific themed track called Cloud Secrets, which we're doing as part of Virtual Azure Community Day. So if you are submitting talks, then look for the Cloud Secrets part. And we've also highlighted what it's all about, because we want to hear about all of the secrets related to Azure Cloud.
Yes. Tell us your secrets.
Yes.
So remember to submit and then the CFP. And also add it to your calendar so you don't forget. So see you on the 3rd of December for VACE. And if you want to contact Cosmos and I, the best way for us is to reach out to us on Twitter. So both of us, we have the DM open. So let us, just contact us if you have anything.
But what's left now? It's to say thanks to everybody listening in. Thanks, Morten, for being on the Dev Show. And I guess everybody, we see you next week.
Yes.
Thanks for having me.
Thanks for joining.
It was a pleasure, Morten. Have a good night, everybody. Bye-bye.